Hi, it's Ms. Hancock again, and today we're going to talk about multiply and divide integers. The standard that we're going to talk about is 7.NS.2a, and what we're going to do is go ahead and look at some patterns and see if we can figure out what the rules are for multiplying positive and negative numbers. And if you see in this first chart right here, we have a column that says multiply, a column that says product. Remember, product is the solution you get when you multiply. You already know that 2 times 3 is 6. You know that 2 times 2 is 4. 2 times 1 is 2. Before we go on anywhere from there, let's talk about 2 times 1. There's a property for that. That property is called the identity property, which means that if you multiply anything times 1, you're going to get that number. Let's go on. 2 times 0 is 0. There's a property there too. That property is 0 property of multiplication. I'm not going to write the whole thing out, but it's 0 property of multiplication. All right, now we're going to stop just a second and we're going to look at the table. Do you notice a pattern there? As we're multiplying and the numbers are, the second term is decreasing, 3, 2, 1, 0, -1, -2, -3. What do you notice is happening to the product? It is also decreasing. So 6, 4, 2, 0. Can you guess what this one's going to be? 2 times -1, and the numbers are decreasing. I think it's going to be -2. Pretty sure about that, because 2 times 1 is 2, and the pattern shows that it's decreasing, so that's going to be -2. Well, taking what you know there, where you had a positive term and a negative term, and you multiplied it and got a negative, this would be -4, and this would be -6. So you see a pattern going on there, okay? All right, now let's look at this other side over here. Let's fill out what we know. What can we figure out over here? I know that -2 times 0 is 0, and the reason I know that is because of the 0 property of multiplication. Anything times 0 is 0. I can come over here, and guys, if you'll look, 2 times -3, -2 times 3, there's a community property there. 2 times -3. Community property says that we can flip those around, or that the signs can flip around right there, and that'd be -2 times 3. And so that's going to have the same solution of -6. Okay, what other one do you think we can figure out? Right here, identity property. I ran out of room to write that, but you guys know that's identity property. -2 times 1, anything times 1 is that number, so that would be -2. Okay. Looking at your pattern that's starting here, I have -2 times 3 is -6. -2 times +2, that would be -4. What's happening to my product? It is continuously going up. It's increasing. So if my product is increasing, -2 times -1, the pattern would continue. That would be +2, and this would be +4 and +6. So let's look at these tables and see if we can figure out a rule. I'm going to go ahead and just erase this part down here with the commutative property. I'm going to erase your properties right here so that we'll have a little bit of room to write and talk about it. So let's see what we notice on this. Here, both of these terms are positive, and I got a positive answer. See, on every one of these right here, I got both terms are positive, and I got a positive answer. So when both terms are positive, I'm just going to shorten it, okay? When both terms are positive, it gives you a positive solution. Okay? Now, let's look at this one right here. What do you guys notice about this? When one term is positive, one term is negative on every one of these. So when the terms have different signs, what would be the solution? Both terms have different signs. The terms have different signs, so the solutions were negative, so that would be a negative solution. Okay. Well, look right here. These also have different signs. -2 times 1, -2 times 2, -2 times 3. They have different signs, and it gives us a negative solution. Okay. So those match up. This one and this one, those two, they match up. But look right here. What do you notice about these? These are two negative signs. When both terms are negative, what type of answer do you get? They're positive. So when both terms are negative, the solution is positive. You get a positive solution. Okay, so we're going to take this rule that we have written down, we're going to clean it up a little bit where it's a little bit easier to understand, but I want you to notice right here, when both terms are the same, like they're either both positive or they're both negative, the solutions are positive. If they're different or unlike, the solution is negative. So we're going to go look at the next page on our slides, and we're going to just kind of look at the rules. Here's your rules. Both terms have like signs, you get a positive solution. If the terms have unlike signs, you get a negative solution. So what we're going to do is we're just going to look at a few problems on that with the rules. So if I have 2 times -3, okay, all that means is two groups of -3. And if we go back to elementary, we know that when you're multiplying, it's just you're separating it into two groups of -3. So if I have negative, 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 that's one group, negative, 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 that's two groups. And so I have two groups of -3. And how many negative signs do I have there? -6. Okay, so this would be unlike signs. And when you have unlike signs, you get a negative solution. Okay, let's look at another one and compare it. What if I have -2 times 3? Okay, and notice I put a dot here. I just put parentheses here. They both mean multiply, so you could do it either way. -2 times 3. This negative means opposite. So this is the opposite of two groups of +3. I'm going to go ahead and write a +3 there so you see that. So the opposite of two groups of +3. So if I have two groups of +3, that's one group of +3, two groups of +3. Now what did I say this meant? Opposite of two groups of +3. So if it's the opposite, what's the opposite of positive? Negative. So I'm going to make every one of these a negative. And how many negatives do I have now? I have -6. Still, if we look at our rule, -2 times 3, they're unlike signs. I have a negative and a positive. Unlike signs make a negative solution. Okay, we're going to look at one more. If I have -2 times -3, okay, and let's talk about what we already know. This is a negative and this is a -3. So this is negative, tells me that's an opposite of two groups of -3. So I'm going to do two groups of -3, 1, 2, 3, 1, 2, 3. So that's two groups of -3. But remember, it says the what? Opposite. So I'm going to change every one of these negatives into a positive because it says the opposite of two groups of -3. And so that gives me 6 positives. Now let's see if the rule up here works. This is a first term's a negative, the second term's a negative. So both terms are like signs. Both terms are negative. So my solution is positive. And so that rule works for that. So that's just kind of a breakdown for that. And we know that multiplication and division are inverse operations of each other. So because the rules are going to work for multiply, they're going to work for divide. So these are our rules. Now, let's look at some divide problems just to kind of get us going on that. -12 divided by 3. Let's look at this. Are these like terms or unlike terms? These are unlike terms. So what is my answer going to be? Is it going to be positive or negative? If they're unlike, it's going to be negative, and then 12 divided by 3 is 4. Okay, so if I had 6 divided by -2, look at your problem. I have a +6 and a -2. Are those like signs or unlike signs? They have, one's a positive, one's a negative, so they're unlike signs, so that's going to give me a negative solution. 6 divided by -2 is -3. What if I had -8 divided by -4? So -8 divided by -4, they both terms are negative. They have like signs. If they have like signs and we divide, that gives us a positive solution. So my answer is going to be positive, and 8 divided by 4 is 2. Okay, so this is the end of our lesson for rules for multiplying and dividing integers. We're going to do another video that kind of goes more into this. This is just kind of like a baby step. This is just talking about the rules and developing the rules. So catch the next video, and I'll see you then, okay? Y'all have a good day.